Hello everyone. Today I'm going to take you through my artificial intelligence project, mainly concerned with cattle breed recognition and surveillance. My name is Waskira Ian, and I'm affiliated to Makerere University here in Uganda. I'm going to take you through understanding the problem that made me come up with this AI project. So the biggest challenge faced by farmers in sub-Saharan areas of Africa is cattle theft or cattle rustling. This greatly affects farmers that have large herds of cattle, since in most cases they are unable to keep track of the large number of cattle that they have. Different scientific methods have been adapted to secure cattle, such as the use of ear tags and the use of skin implants to keep track of their actual position. These, however, have proved to be very inefficient since ear tags can easily follow, and the trackers at times affect the health of the cow. To also add, installing these trackers into the cow is quite expensive because you have to hire a veterinary doctor to do this implantation. So it's also very costly in terms of labor. This AI project is meant to keep track of each breed of cat available on the farmland and its current position in order to allow thorough planning by the farmer and also to fight off cattle theft. These cameras shall be installed at various locations around the farmland. These cameras provide images that shall be used to keep track of the number of cattle on the farmland, including the count of each breed. For AI accountability, the AI should be able to perceive data in an unbiased manner. This can be done through feeding the AI model with a variety of data in order to categorize only cattle and differentiate other moving items from the cattle. For example, human beings, other animals, and birds. This can ensure that data used is trustworthy and thus reducing the possibilities of bias, inequality, or any other societal issues. Detailed records of the decision-making and design process shall also be kept to encourage the best practices and encourage iteration. The iteration means that developers that are building onto this project can easily understand what was done before, such that they can build onto that, and so do the users. Then the workings of the AI model should also be clearly understood. The ability of the AI model to keep a real-time count of the cattle on the farm shall enable farmers to make proper planning for their cattle, especially in terms of feeding, milk collection, vaccination, and crossbreeding. So this is quite important to the farmers because they need real-time statistics on most of these things, and this can easily provide them with such data. Then the system should also be able to reduce the cases of cattle rustling and theft. The ability of the AI system to keep a real-time count of the cattle they shall be having. That means that they can easily um, have a bird's eye view of the entire farmland and thus protecting their cattle from theft. The AI system is going to be based off the use of images to study and train the model on 5 different breeds of cattle, which include the Frisian cattle, the Red Den cattle, the Brown Swiss cattle, Jersey cattle, and Ayrshire cattle. This model is going to be largely used for cattle identification and surveillance since it's targeting cattle farmers. The model is going to take advantage of image processing using convolutional neural networks to differentiate one cattle breed from the other. In the problem statement, the first thing is the need for cattle farmers to keep track of all the different breeds of cattle they have on their farmland. The second is to fight against cattle rustlers and thieves that kill and steal farmers' cattle. The third is the need to carry out proper planning for cattle, especially in terms of vaccines, food supplements, and milk production estimations. So in answering some of these research questions, first of all, the model selected has to be categorical due to the different categories and the different breeds of cattle in the dataset. The datasets chosen in this case is fit to the model due to the different breeds being different categories inside the dataset. Then the model shall also train through plotting data on a nonlinear graph, which then measures the difference to guess whether the data is particular category or not. In my hypothesis, each cattle breed has different features over other cattle breeds. So the hypothesis is to find out whether it is possible to uniquely identify each cow according to their unique features. And that each cow, according to the unique features that each cow has over another. So for example, the Frisian cattle has black and white patches compared to the red Den cattle that has predominantly reddish fur and skin. So the main research objective here is to correctly train an image classifier to get the best accuracy for predictions on the data set, from a data set based on the different cattle breeds. For the research objectives, my data set mainly is from Cargo, and the link is there. It is composed of pictures from 5 different breeds of cattle, including Ayrshire cattle, Brown Swiss cattle, the Holstein Friesian cattle, Jersey cattle, the Red Den cattle, and the Red Den cattle. The Ayrshire cattle has 260 image files. The Brown Swiss cattle has 238. The Friesian cattle has 254. The Jersey cattle 252. And the Red Den has 204 image files. The cattle images have different backgrounds, including grass, trees, and other cows in the background as well. So I'm also going to take you through the machine learning model interpretation. So in the process of interpreting what comes out of the results that come out of the model, we need to expose it to different kinds of environments. This can easily be done using the local interpretable model and anagogistic explanations, which is short for LIME. It can be used to help users of the model to understand how the model makes its predictions, through finding out how predictions change when we perturb the data samples. This can be done through dividing a particular image into interpretable components. And then LIME generates a data set of the perturbed instances by turning some of the interpretable components off. That means that particular features that are particular to a given cow are turned off, and in every perturbed instance, the person can get the probability that a cow is in the image. So in this case, we can get the probability that a given cattle breed has been shown up. In the end, the components with the highest positive weights are presented as an explanation. I'm going to acknowledge great work done by W. Andrew, C. Greatwood, in the book, The Visual Localization and Individual Identification of Holstein Friesian Cattle via Deep Learning. I'll also recommend the work of Jalmans, G, and No Uzon, M. Zahid and Gabutz, and Kovac on detection of breed classification of cattle using YOLO, the V4 algorithm. Thank you so much for listening, and I'll update you more as we go on. Thank you.